Hi, my name is Danny, and I'm going to be talking to you about an experiment involving dry ice and a color change using universal indicator. First of all, some background information on universal indicator. So, universal indicator is a mixture of various indicators that change color at different pH levels. They vary from reds, which is below around 3, go up through neutral, which is 7, up through oranges and yellows to get there, and then we transition into more basic territory and basic pH levels. From 7 onwards we start to go blue, and then into a fuchsia coloured indigo violet colour, as represented by this colour chart. As I said, the components of universal indicator are various. You have thermal blue, which go from this low pH range from 1.2 to 2.8, and I'm not going to go through every single constituent here, but what we have here is you start to see that we're going to start out very red in the extreme acidity. Below 3 is going to be red. Then we transition through, and you get a blend of these colors as you go. So the red mixes with this yellow, mixes with this red, and becomes a dark orange. And as the pH level rises, you start going through into just yellow as you come through all of these. And then to the upper level, we start to get into the greens and the blues and the indigos. So the reaction we just saw actually has multiple stages, and I'm going to break these up one at a time and talk about them individually. Stage 1 is actually the reaction between the solid carbon dioxide or dry ice, which sublimes and reacts with water to create carbonic acid. So we have our water, we have our dry ice. Sublime is the process by which a solid turns into a gas. It doesn't go through a liquid phase, which if we think of ice and water, it's a little confusing to think about that immediate transition. So this is in equilibrium, and it creates our carbonic acid, which is then a major part of the reaction going forward, and carbon dioxide gas, which is what you see bubbling up from the bottom of the beaker. On the top of the beaker, it looks a little bit like a witch's cauldron, with the mist rising off the top of it. That's actually not carbon dioxide, it's water vapor. Stage 2, this is the acid-base reaction between sodium hydroxide and carbonic acid. Carbonic acid neutralizes sodium hydroxide to create sodium carbonate and water. Once the sodium hydroxide is neutralized, the pH is pushed into the acidic range. So we get carbonic acid reacting with the water to create hydronium and bicarbonate ions. As you can see here, this is an equilibrium reaction. The carbonic acid is a weak acid, so it doesn't fully dissociate. This is an interesting reaction. These components here, they're actually essential key components in photosynthesis, and this is essentially how the mesophyll within the leaves of a plant absorb carbon dioxide. And the final stage is really a separate reaction. Since carbonic acid is a weak acid, hydrochloric acid is introduced to push the color change of the universal indicator into the red range, representing a pH of less than 3. So we have the hydrochloric acid reacting with water. This is a strong acid, so it fully dissociates into hydronium ions and chlorine ions. Thanks for watching. I look forward to seeing everybody else's videos. See ya.